Okay, so thought I'd start here as a nice wee intro. Okay, so the non-calculator paper started with a very similar question. Okay, there were some interesting answers, but let's just go over and just make sure we're all on the same page with this. So this is functional notation. Okay, this type of question is functional notation. And it's just writing the equation out in a slightly different way. We are more used to equations being written like something like that. Okay. Functional notation changes that up a bit and puts something in the bracket. So the function of x is equal to x cubed minus 2. Okay, so that's what it's telling you, the function of the letter x. Now remember, x is just a variable. Okay, x is just a variable. Don't worry too much about what that letter is. That's just a sort of placeholder. The water melting one, no trouble. That's just a placeholder, that letter. Okay, and that means we want to substitute something into that position. So when it says evaluate and in brackets -3, okay, what that's telling us is that x is -3, okay, and that gets substituted in wherever you see an x within that term. Okay, now there's two ways they can ask you this, okay, but this is, turns out, probably the most common way. Okay, so if we do a function of -3 equals x cubed minus 2, what we're looking to do there is put in -3 into that position. Okay, so we're substituting in the missing variable. Okay, so that would be -3 times -3 times -3, essentially, if it's non-calculator. Okay, so that's +9, -27. Okay, -27, -2, and -29. Okay. So we're substituting in whatever that letter is. Okay. So you can see the way they've written that is the same as the format of that. Whatever's in that bracket is substituting in where the rest of the x's are. Okay. Once you get that, it's usually quite a nice question. All right. But some people didn't pick up on that too well. Let's have another look. I've only just started going through these. Okay, so no, sorry, started going through the past paper to pick out questions. This question on the calculator paper, I'd say, was one of the worst in regards to being answered. All right. And it's worth quite a lot of marks. And it's actually not that bad a question. All right. What people were getting thrown with, or probably, is the fact that there's two triangles there. And that was just mixing you up a bit between the right angle triangle, okay, and then the really big triangle, the non-right angle, to that one, and then the big one, which is everything together. All right, so people were throwing out distances and angles and all sorts of fun. So there's really three triangles making up this question. Okay, so it's understanding which one that you want to work with. Okay, and then working out what rules apply to that. So what do I mean by what rules? Well, the rules that we use for right angle triangles. Okay, the right angle only. Yeah. Okay, is that a squared equals b squared plus c squared? which is our long side squared equals our short side squared plus our short side squared. Okay. And our SOHCAHTOA rules. Okay. Now these only apply to right angle triangles. So that's sine of the angle equals opposite over hypotenuse. Cos of the angle equals adjacent over hypotenuse. And tan of the angle equals opposite over adjacent. Okay, only right angles. Skip a page too quickly, give me a wee shout. Only non-right angles. Given in the formula sheet. All right. The non-right angle rules are given in the formula sheet. So we've got the sine rule, which is A over sine A equals B over sine B equals C over sine C. Okay. And then you've got the cos rule and the area of the triangle as well. I won't write them out. They're on your formula sheet or any formula sheet you pick up. Okay. This is the rule that we wanted in this question. Okay, so once you see triangles, even though there's multiple triangles, 2 seconds. Once you see triangles, first thing you want to determine is it a right angle? Okay, is that not right? Is it a right angle or is it a non-right angle? Triangle. Okay, and then you determine which rules you can use, and then you try and work out as many angles as possible. Okay, so given a bunch of stuff here, we want to calculate BC. We'll identify the side that we're trying to calculate. So it's letter B to C. Okay, that I've identified in pink there. Okay, what are we given? Well, we're only given C to D. Okay, and that is a side. That is one of the sides of that triangle there that I've outlined in blue. Okay, now we've only got that bit of data. So that points at that triangle that we need to start there. Okay, we can't start with oops. We can't start with that triangle I've outlined in orange. Okay, we can't start with triangle ABC because we've not got enough information. Okay, so sort of ignore that and look at the other triangle. We've got ACD. That triangle, we've got a length on it, and we've got one angle. Now, can we find out any other angles? Okay, well, we've got enough information to find that angle there, ACD. Okay. Is 160, 152 degrees. Okay, we've got enough information to figure out that angle in there. Okay, that's a good place to be. That means we've got two angles of that triangle, all angles in a triangle, so the three angles add up to make 180. That means angle CAD is equal to 180 minus 152 minus 20, minus 12. Which is 164, so 16 degrees. 16 degrees. We've now got three angles, one bit of information. Now, we can't really do much else here. We could find out this angle in here, but again, that doesn't help us until maybe later on. Okay, but we've got all the angles and one bit of information there. What are we trying to figure out? What would help us find BC? Well, if we found the distance AC, we found the distance from A to C. Okay. We've then got the hypotenuse of that right angle triangle. And we've got one of the angles of that right angle triangle. And that's enough information to then find a missing side. So we want to find this length, this distance AC first by using our information in our non-right angle triangle, ACD, okay, to find that missing side, that AC side. So we want to find AC. Now that's a non-right angle, so the triangle I've drawn in blue, outlined in blue, is non-right angle. Okay, looking at your formula sheet, you've got a couple of rules. We can use A over sine A equals B over sine B equals C over sine C. Okay, or you could use a cosine rule, but we're just going to focus on the sine rule right now. Okay, now I'm going to pull that triangle out, and I'm going to do it on a separate page. Maybe not an orange. And I'm going to isolate that triangle. Triangle. Okay, so 1, 5, 2, 12, 16. Okay, and we get given this length here, 15 meters. Okay, and we're trying to find this unknown. I'll call it X meters. Okay, now I said multiple times that we want to use this sine rule. Now, the hardest thing with these rules is understanding what the letters are telling us. Okay, but you need to get good at it. Okay, now, how do I label up that triangle? I've completely isolated it. Okay, I've taken it away from that ACD. Okay, taking it away from that. I can either put on my own labels or use the same letters. Okay, I'll use the same letters. I'll show you. That's A. That's C, and that's D. Okay, now that's A, B, C. Again, they're just letters used for variables. That can be any letter, any Greek symbol. It's just a space in which we can put a number. All right. So A is just, it could be anything. Okay. Now we do have a letter A, so let's keep things simple. Let's make that. Okay, that angle on that side. Okay. Now here it gets a wee bit confusing. This angle here is called C. Okay. Well, let's keep it simple actually. We can make that the C bits. Okay. And then the D bit. Okay. Well, that has to be in here. So the labels won't always match up with the letters that you're given in the formula sheet. Okay, that's a given. Okay, but these letters are literally just a place in which we can put numbers. Okay, they don't have to be that letter. You don't have to see an A to label it an A. Okay, so the small letter A in the formula is the side length of the side across from whatever we've selected as angle A. Okay, so we've selected this as angle A because it's labelled A in the question. Okay, so 16 is angle A. And the side opposite that That one there at 15 meters. So let's put that in. 15 sine 16. Okay. Now, we've not got a letter B here. That angle 12 is labelled D in the question. Okay, so that it's a different letter on the formula sheet than it is in the question. That's fine. Okay, don't panic at that. That just means that letter has to be associated with the side across from it. That's all it is. Okay, so I could rewrite that wee bit as D, sorry, small d, over sine D. Okay, means the exact same thing. Okay, it's just the letter you use. Okay, so we don't know what that side opposite is, but we know the angle. Okay, so the angle with which you're working, in this case the 12, the side opposite it is what makes up that part of the formula in the sine rule. Okay, have I lost anyone? Am I not explaining that very well? All right, and then the last angle is your 152, and that's opposite this side here, which we don't know the length of. We'll call V for no reason at all. In fact, small c, call it small c. Make more sense. All right. So, what do we need to do? Well, when we're using the sine rule, we have to only use two parts. Okay, so that's one part. That's two parts. And that's three parts. Okay, now we can use 1 and 3. Okay, or 1 and 2, or 2 and 3. Okay, but you only need to use two parts of it. Now, what are we trying to find? Well, we need to try and find this unknown x. Okay, we're trying to find this unknown. Okay, so we're going to be using part 2, so we can rearrange and find that unknown. Now we need to use one of the other ones. Well, we need one of the other ones to allow us to find that unknown. We need it to be complete. The only other one that's complete is number 1. We can't use 2 and 3 because then there'll be two unknowns. We don't know the length of side C, so we can't use that if we want to find out part 2. Okay, so we have to use 1 and 2 here. We ignore part 3, and we can rewrite that then as 15 over sine 16 equals x over sine 12. Okay, and that's the equation we take forward. We take that forward by rearranging it. Okay, so we take that forward by rearranging. So 15 sine equals x over sine 12. Okay, and we're looking to find x. Okay, now, best way to do it is have x on the left-hand side. Okay, so we can just spin that round, remember? So we're not changing side, changing sign at this point, we're just spinning it round to keep it sort of neat. All right, so we can rewrite this whole equation, not moving anything at this point. Like that, so that x is on the left-hand side, so we keep it the same. That line and that line is exactly the same. We've not done anything. Okay, I've literally just swap left-hand side and right-hand side, so the X is on the left-hand side. Okay, so just be careful with that. Just be very, very careful with that. Okay, you're switching the whole thing if we've got that equal sign. Okay, so I'm not taking anything across at that stage. Now we want to isolate that X term. We want to isolate that X term. And we do that by taking everything around it away. So we take that whole bottom line fraction, take it across to the other side. Now that sine 12 is a divide. So that means on the right hand side it becomes a multiple. And everything's over sine 16. Okay. So it's 15 times sine 12 divided by sine 16. Okay. So our missing side, 15 sine 12. I'm getting is 11.3. Let's do it to two decimal places and come back and see. 11.31 meters. All right. Yes. We don't inverse sine because we're taking the number along with it. Okay. So someone's asked, why don't we inverse sine when that goes across? It's because the number's coming across with it. Okay, so the whole sine 12 is moving across that whole term. If it was just the sine part, which we do in other questions to do when we're doing the castrals, etc. Okay, if we were just moving the sine part and leaving the 12, remember that means sine times 12. Okay, so sin is essentially something on a standalone term. So it's sin times 12. So I'm moving sine 12 all at the same time, not just sin. Okay, so remember when we do the other type of questions, we move sin away or sine away, okay, to isolate what it's been multiplied with. At that point, it becomes inverse. But when we do it this way, we're taking the whole thing. Okay. That points me at where we want to do the next question anyway. So we'll do one of those questions next, and I'll show you what I mean by that. Okay. So because we're moving sin and the term beside it, it stays the same. Okay, anyone not getting that in a calculator? Are we happy with that? 11.31. What have we found out? We found out this side here. Okay. We found out that side there, that side there, that triangle. That allows us now to isolate this right angle triangle to find what we're after, BC. Okay, so let's draw out that triangle. And they have labeled the right angles there. That's 11.1. And we get given that angle, which is 20. Right angle triangle, where we've got the hypotenuse. Okay. The hypotenuse, the longest side in a right angle triangle, is always opposite the 90 degrees. The longest side of a right angle triangle is always opposite the 90 degrees. Okay. So you don't get given the right angle rules, you need to remember it. Right angle rules are the Pythagoras. Okay, I write it out, a squared equals b squared plus c squared. All that means is a is the long side and b and c are the two short sides. Okay. Can we use that to find BC? No, because we need at least two sides to find the missing one. Okay, what we need to use instead is our SOHCAHTOA rules. Okay, what we need to use instead is our SOHCAHTOA rules. So I'll just remove that. I'll just remove that as well and write it. Okay. What we need to use SOHCAHTOA. Okay. What have we got? What are we trying to find? Well, we're trying to find BC. We've got an angle, 28 degrees, and we've got the hypotenuse. Okay, so let's look at SOHCAHTOA and break down each and see what we've got. What we need is two parts to find the unknown. So we need either the angle on one side or we need two sides. Okay, so it's got an angle. So I'm going to tick the S, the C, and the T. The fact we've got 28 degrees doesn't matter whether it's that one or that one. Okay, it just matters that we've got an angle at this stage. So we've got an angle, so I can tick the S, the C, and the T. We've also got the hypotenuse. So I can tick the H here. The H stands for hypotenuse, and I can tick the H here. Now what this does, because we've got no other information, what this does is allow me to cancel out the tan. We've not got enough information to use that. Okay, we've not got enough information to use the tan because we've not got the opposite or adjacent sides. Okay, we're missing those sides. Now it comes to what are we trying to find out? Well, we've got this angle 28 degrees here. Okay, so this is our angle of interest. This is what we're using. So our opposite side is the opposite side to this angle. The adjacent side in our calculation is the adjacent side to this angle. Okay, now that's important because it differs in what angle you're using. So it's the opposite side to that angle or the adjacent side to that angle. Now, opposite, pretty obvious. The opposite side to that angle would be AB. Okay. What's sometimes a wee bit trickier is the adjacent side. The adjacent side, adjacent just means beside. Okay. Adjacent is the side that touches the angle that you're using that isn't the hypotenuse. So the side that's touching the angle that you're using that isn't the hypotenuse. So that's our side AB. Okay. So we've got enough information to find O, the opposite. Okay, but that's not what the question's asking for. We've also got enough information to find adjacent. That is what the question's asking for. So we're using the cos of the angle equals adjacent over hypotenuse. That symbol, it's just theta, it's just a Greek letter, okay? Again, It's just a place mark for where a number can go, where a variable can go. So it's cos 28 equals the adjacent side, which is our missing side, which we can call BC, okay, because it's between letters B and C. And the hypotenuse we found out last part of the question, 11.31. Okay, again, we're trying to find BC. I'm going to flip this round, so BC is on the correct side, okay, and then it's going to do this again. That bottom part is going to come across and it's going to become a multiply. $11.31 multiplied by cos 28. 9.99 meters. Let's see what the question's asking. It doesn't ask for significant figures or anything. Okay, so 9.99 meters is a good answer, or if we were rounding that up, I reckon you could round that up to 10 meters. All right, it's absolutely fine. So that side from B to C is 10 meters. Now, that took me probably about 20 minutes. All right, obviously I was explaining every stage. So that might take you 5 minutes in the exam, 10 minutes at a push, okay? It feels like a lot of work, but it's actually not too bad. You're just using two rules to find two sides of two different triangles. A lot of people miss that out. Since I've got Gary's in front of me. So a lot of people missed that out. I think that's the entirety. Yeah, so that was a question 13 on your calculator paper. Now that was the same as question 13 on your calculator paper, but that's the past paper 22. I can't show you your past paper questions tonight because I'm not allowed to record them. Well, that's why. It's like you would sell them in the black market. Is there a black market for prelim papers? That's what it felt like. It felt like a criminal when I asked the question. Any questions on that? We good? It's the time. What other question? Bad. That was bad. Tell you what, simultaneous equations, you guys smashed. Very good at simultaneous equations. Dreadful at everything else, but very good at simultaneous equations. Right, wait. There was one where we had to create our own equation. And an expression for triangle. Just try to find a similar type of questions. So it's the one you had to make your own equation was really badly done. Let's have a look. I'll do that. I will do that. See how I'm just give me one of these questions. I can't show you that exact question, by the way, but I'll try and find one somewhere. Oh God, we did one in class like it. I can't remember what the hell it is. Oh, come on. I want to find it. I want to find it. I want to do it with you. Tell you what I could do. Sorry guys. Sorry guys. Essential skills. That. This is. Sorry guys. Sorry guys. Right, so you had a very similar question. Oops. In your exam, in your prelim. So this question that I've pulled up is 2015 past paper. All right. It's asking us to create our own expressions. Now, this is quite difficult and it does take a wee bit of practice. So write down our own expressions of the card in terms of X. Okay, think, yeah, you had a very similar one. I don't think many people got it at all, to be honest. So let's have a look at this. Go through it. Write down an expression for length. Okay, so first part of the question, write down an expression of the length in terms of X. Okay, now let's have a wee look at what it's asking. So length is the full length from outside edge to outside edge. Okay, now you're given this dimension here, this 13, which is your inside edge, inside edge. Okay, so the length, the total length of that is that 13 plus that X term there, which goes all the way around. Okay, that's the thickness all the way around. Zoom's really annoying. That's the thickness all the way around. Okay, so you must have an X here as well. So the length is equal to 13 plus X plus X or plus 2X. All right. I think that was worth the 1 mark. Yeah, that was just worth 1 mark. All right. this question, this past paper question, I think is actually quite poor. Remember, we did this in class actually, and I said it almost doesn't ask you enough, but they're saying hence show. Okay, now what they're asking here is what the area is, because you've given a wee bit of information. It was a better question they asked you actually in this, in the actual prelim. All right, so it gave you that information. But hence show this. So you're starting out with your final answer. So this is where we're trying to get to. Okay, this hence show means you need to get to this as an answer. All right, I think most people understood that part, but then sort of got lost and jumbled up. So essentially that's saying hence show that this is the area of that picture frame. Okay, so a rectangle picture measuring 9 centimeters by 13 is placed on a rectangular piece of card. The card area is 270, there's a border of 1. Yes, this was a non-calculator, wasn't it? Only a non-cal. Right, so area is 270 as a border. Calculate x with the border. Okay, so what's asking you for part 2 is to also find the width. Okay, width is equal to 9 plus 2x this time. Okay, and then working out the area of the breadth. Better call that the breadth. Width or the width. Area equals length times breadth. Okay, which is equal to 13 plus 2x multiplied by the 9 plus 2x. Okay, that's the step that a lot of people sort of didn't put together. All right, it's asking you to find the area, so hence show that, and there should be, this is what annoyed me in this one, that should say hence show that the area is, that's what that question should ask in there. Missed that out, which I expect well. Okay, so now we just break that down. So 9 times 13, 117, 117. Okay, 9 times 2x is 18x. X. Right, okay. Sorry, I thought I was going crazy. That's equal to 117 plus 44x plus 4x squared. Now, what else are you given in this question? You also get given 270 as the area. Okay, so where are we for area? We could say 270 equals that, 270 equals that, 270 equals that. Now it wants us to leave it with 0 on the right hand side. Okay, so we want to leave it equal to 0. So we're going to bring over that 270 to this side here. Okay, that becomes 117 plus 44x plus 4x squared minus 270. Tidying that up and rearranging it. 4x squared plus 44x. Bringing the like terms together. Minus 153. Okay, if we flip that round so that the zero's on the other side. Okay, we've just spun that equation round, we've not changed everything's side. Okay, that makes sense. So that line and that line is exactly the same. Okay, we've just changed the left and right hand side. Okay, so I think it was actually better worded than the prelim. All right, it was actually better worded and better structured than the prelim. All right, believe it or not. It still causes a wee challenge. Second part, B. Okay, is we take that 4x squared plus 44x minus 153. Okay, it's paper 2, so we'll use the equation. Okay, 4x squared plus 44x minus 153. Now, to do B, what was B worth in it? Which is worth 4 marks. Okay, so that second part's worth 4 marks, quite a lot of marks, all things considered. All right, you don't have to be able to solve that. You get given it. That's the part we take forward into the next question. Now that happened in the prelim as well. So if you get lost when you're doing all this, which is easily done, especially in a pressurized situation, okay, get as far as you can, but you're trying to prove this, so they've given you enough information to do the next step. All right, that was the case in the prelim as well. You had enough information to do part C as it was in the prelim, okay, with what you had, okay, in the previous part of the question. You didn't have to find it. All right, so if you got stuck there and you got lost, you still had enough information to solve and get another 4 marks. Okay, so 4x squared plus 44x minus 153 0. Okay, now they're asking you for a value of x, so they're asking you for a solution. What solution would make sense? Okay, now this is a quadratic, so to find the solution of a quadratic, essentially it's asking us to factorize that. So what we're doing is factorizing. Now this is in the calculator paper. It's quite a difficult looking sum. So what I'm going to use is the formula sheet. Okay, and use our x equals minus b plus and minus root of b squared minus 4ac all over 2a. Okay, I'm going to take this bit to one side. I'm just going to do it over here just to keep it nice and neat. B squared is 44 squared minus 4 times 4 times minus 153. Okay. 44 squared is 1936. Minus 4 times minus 153 times 4 is going to give us a positive. Okay, just be careful with that. I'm getting, just going to find the answer out. 4 times 4 times 153, 2448 plus 1936. Okay, and then we put that back in here. So minus b is minus 44. plus and minus root 4384 all over 2 times 4. Okay, remember we split this into 2. Take one side over here, plus root 4384. And we do another one, which is minus 44 minus root of 4384. All right, so you're doing it twice. You're going to get 2 solutions out. All right, you're going to get 2 solutions. Put them on your calculator, minus 44 plus root 4384 divided by 8. Oops. 2.78. Okay, and do that. Push. Minus 44 minus root 4384 divided by 8. And we have a negative number. 4.78. Okay. The last part of this, you need to specify which one is the correct answer. So we've got 2 solutions, 2 possible solutions. Now look at the question. We've worked out values for x. Okay, so by factorizing it, we've worked out potential values for x. Now, x in the question is the thickness of that border. Okay, x in the question is the thickness in that border. The thickness has to be a positive number. So it has to be 2.78 centimeters. The thickness of a border can't be negative. Can't have a negative size border. Okay. So it cannot be negative 13.78 centimeters. Specify that. Okay, so that's past paper 2015. Question 14, paper 2, so your calculator paper. All right. Oh, wow. Okay, indices. Yeah, there was a few wild answers going on here. It's interesting. So let's go through the rules of Indus. Just work out where we're going. Okay, so rules of Indus. There's 2 things going on here in this question. Okay, we've got this top line where we're multiplying 2 indices. Okay, and then we've got this bottom line. Okay, well, we need to take into account the indus. Okay, but we're dividing this time. So there's 2 separate operations going on here. Okay, so it's all about the order of which we do it. Okay, and how tidy it is, etc. Now, the rules of Indus, when we're multiplying that Indus, okay, the numbers in front of the Indus, okay, so in this case, there's a 1 in front of that. Now, we don't write it in algebra, but there's a 1 in front of that. So the 2 numbers in front of it, so if I just focus on that top line first, sorry, if I just focus on that top line first, and tidy that up. Oops. if I just had n to the power of 5 multiplied by 10n, okay. In algebra, we don't write that number 1 in front of there. And if there's n, okay, that must be the power of something, so that's power of 1. Okay, remember something to the power of 0 would be written as the number 1. Okay, so if it's just the letter, then it must be to the power of 1. Okay, but in algebra, they don't write it because they like to confuse you. Okay, now, rules of Indus, the numbers in front, when we're multiplying, get multiplied together. So 10 times 1 in this case. So the answer is going to have a 10 in front of it. And then it's going to have the n. And then we're multiplying it. We're adding the Indus together. Okay, so we're multiplying the two terms. If they're indices, then the multiply means we add the indices together. Okay, we don't multiply them, we don't do anything like that. Okay, so that top line would equal 10n power of 6. Okay, so I'm going to take that, and I'm going to write it 10n power of 6. I'm going to do 2n2. Okay, so now we've got one single term on the top and one single term on the bottom. Now the numbers in front of the n, or the numbers in front of whatever letter they use. What letter did they use in the prelim? Let's have a look. Oh, I'm going to go over changing the formula. Oh God, that was a shocker. I think they used X in the prelim, it doesn't matter. All right, whatever letter they've used, the numbers in front of it, okay, can simplify down. So we're going to simplify 10 divided by 2. That's nice and easy. All right, if I just draw that, then it just equals 5. 10 divided by 2 is 5. Now it does the exact same. So that can simplify down to 5 n over 6 over n to the power 2. All right, so I've just simplified that fraction. Okay, now we need to take into consideration the fact that we've got an indus in the bottom of that fraction. Now, indices in the bottom of the fraction means that when we are simplifying it and solving it, that indus, when we bring it up, becomes a negative. So that'll be 5n6 minus 2. That indus in the bottom becomes a negative. So they're the same letter. Okay, in this case it's 2 n's. If they're the same letter, then the indus above the bottom letter becomes a negative when we go up the top. All right. Now, that's like a multiply, we add it together. Divide is the opposite of a multiply, so we take it away. Okay, something, I don't know, that helps. So that's your final answer. Okay, left you the wee problem. Okay, so we look. Leave my screen. Okay, left you a wee problem. Two things going on here. Got one part of the problem here, and then the second part is involving this, and then we need to tidy it up at the end. Okay, so let's just do one step at a time. This part of the question, okay, what this is telling me to do, my rules of Indus, okay, is this 2 and this 3 on the outside of the bracket, okay, have to multiply together. That part is n2 times 3 to give us n to the power of 6. Okay, so that's not the same as when we multiplied it, so n squared plus n cubed. Okay, what that is actually saying to me is n squared plus n squared plus n squared. Oh, sorry. Why? N squared times n squared times n squared. Okay, so n squared cubed is multiplying by itself 3 times. Okay, so it's n2 plus 2 plus 2. It's n to the power of 6. Okay, so be careful there. That was slightly different to what I showed you just before. So n to the power of 6. So the solution, or is the solution for that part there. Okay. So with that in mind, I can then rewrite that as n to the power of 6 multiplied by n to the power of negative 10. Okay. Now, just because that's a negative doesn't change the way that we work with this. Because we're multiplying two index terms together, n6 plus n negative 10. Okay, essentially taking negative 10 away, so we're getting negative 4. Okay, so a negative on the top line fraction, okay, or the top line, okay, means if we want to leave it as a positive power, we need to put it at the bottom of a fraction. Now, remember, there's no number there, but we can write a number 1 in front of that, in that term. Okay, so when we move n to the power of 4 to make it a positive term, to make it a positive power onto the bottom of a fraction, fraction becomes 1 over n to the negative, oh, not over, n to the positive 4. Okay. Now, just to show you what I mean there, if we had 5n to the power of negative 6, we could leave that as 5n to the positive 6. Okay. So just because there was a 1 in front of that, that's why the fraction has 1 on the top, the number 1 on the top. Okay. That sometimes throws people because we don't write it out. Okay, just be careful with that. Because we don't write it out, okay, doesn't mean it's not there. Any questions on this? Okay, it's just about going through it step by step and not trying to jump to the right answer. Okay, so we've got some weird and wonderful things going on there. Okay, so wee question. Well, I would say yes. So the question was, does it always need to be positive? I would aim to always leave a positive. In this question specifically, it said give your answer in a positive power. That's because they know at this stage you're going to get a negative power and they want to just take that extra wee step. Okay, so if they're saying leave it with an positive power, then obviously yes, but always go for it. Always aim to leave a positive power for yourself. All right, so if you're left a negative up the top, you can take that down. Oh, they can mark it down for anything. Yes, they'll mark it down for that. Because it's asking for a positive, leave a positive, then definitely mark it down for that. Always positive. Okay, so I said we'd look at volume, that volume question. Okay, so the question wasn't specifically working with volumes, it was the second part of it where it was asking us to do something and work out a height. Essentially what it's asking us there is to use the formula that we're used to, but find a variable. So find the letter H in that formula. So obviously can't show you the same one, blah, 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 blah. But this is quite similar, okay? So I'm going to show you, I'll go through 3 of them with you. Okay. So part A of that question, calculate the capacity of the mug. Okay, now in your formula sheet, you don't get given the formula for a cylinder. The formula for a cylinder is just working out the area of the face. Okay, in this case, that circle there, working out the area of that face using pi r squared and then multiplying it by the height. Okay, so if it's the same shape all the way down, then it's just the area of your top cross section multiplied by the full height. Okay, so the area of the circle is pi r squared. Again, you don't get given that in your formula sheet, you have to know that. So the area of that blue circle that I've put up there is pi times 5 squared, which is 78.5 centimeters units squared. Okay, so remember the areas are squared. So length would just be centimeter. Area, centimeter squared, and volume would be centimeter cubed. Okay, so the area of that blue circle, 78.5. The volume, the whole shape, is the area of that blue circle times the height. Okay, so pi r squared times the height. So we'll try to find the volume. So it's 78.5 multiplied by the height, 14. That's given us 78.5 times 14, 1,100 centimeters cubed. Okay, 1099, just round it up. Okay, that's the first part of that question, probably worth 1 mark. The second part of the question is a wee bit more complicated. Okay, so it's giving us a volume and it's asking us to work out the depth. Okay, so part B, this question, we're still using the fact that volume is equal to the area of the face times the height. Okay, the height in this case will be the depth. Okay, so the depth of the coffee will obviously go from the bottom to wherever the top of the coffee is. The area is still going to be the same. So the area of the bottom of that mug is still going to be the same as top of that mug. It's a perfect cylinder. So the area is still going to be that 78.5 and it's given us a volume of 600. So we're putting in all the information that we know. We're given a volume of 600. We've got an area of 78.5 and we're multiplying that by H. All we're doing is solving for that letter. Okay. So 600 divided by 78.5 is the height or the depth. Okay, we can use the letter D there. Okay, so 600 divided by 78.5 it's given us an answer of 7.6. Does it ask for? Doesn't ask for anything in particular, but so we'll do it to 2 decimal places, and that's in centimeters, and that's the height or the depth. Okay, so we're using the exact same formula. In this case, the cylinder one, which isn't given in your formula sheet. Okay, using the exact same formula, but finding a different variable in it. Okay, so the question in the prelim asked you the depth if the cone melted. So you had the volume of the cone, so you had the volume. Okay, if it melted, it would have turned into a rectangle. Okay, so if the cone had melted in the prelim question, it would have turned into a sorry, a cuboid. Okay. Right, cube volume. That volume would equal length times breadth times height. Okay, so your volume you found in part A of the question, say it was 1,000. Okay, if your volume was 1,000 of that cone, that's going to stay that same volume. It's have the same volume of liquid. Okay, if it melted down, you're just equating that then to your length times breadth times height, and you're given the length and breadth in the question. So if I had 1,000 in my imaginary box, I had a length of 10 and a breadth of 40 times h. Okay, that'd be 1,000 equals 400h. So h would equal 1,000 over 400. Okay, run out of space. Back, it's giving up on me. Okay, 1,000 over 400, which is 25. 2.5. You'd have a depth of 2.5. So in the prelim, that's what the question was asking you. Okay, so actually change shape. So that's the wee complicated bit. Why is that not going away? All right, the wee complicated bit there in the prelim question was it was going from a cone volume to a cuboid. Okay, but you had the length of the breadth of that bottom surface. You were just working out the h with that volume. All right, let's give another one of these. Oh. Yeah, hopefully you can read that okay. Okay, so drinks container, shape of a cylinder. Okay, so you don't get given that formula. You need to know pi r squared for the area of the circle multiplied by h. Okay, calculate the volume of the full drinks container. Give your answer in cubic centimeters to two significant figures. Same process as last time. Find out the area, that surface there. Okay. Oops. Pi r squared. Pi times 20 squared. Pi times 400, 1200. Pi squared times pi. 1256.64. Okay, so the volume is equal to the area multiplied by h. 1256.64 multiplied by 50 equals 62831.85. Okay, it's asking in the question, just be careful with this, two significant figures. So we go to our number, 1, 2, put a line down. That's our significant figures. If the number on the other side of that line is above, or sorry, is 5 or above, then we round up. Okay, 63,000 centimeters cubed. Okay, so you'll get a mark for that. So that's probably worth 3 marks. Okay, the second part of the question is where it comes into we're filling another shape and find out the size of that or find out the depth of it. Okay, the shape in question is a cone. Okay, the shape in question is a cone. Now, in your formula sheet at the front of the paper, you're given the area of a cone, or sorry, the volume of a cone. Volume cone. third times pi times r squared times h. Okay. What will the height of the liquid in each cup be? We're looking for h. Do we have r? Yes, it's given in the question. Pi is a constant, a third is a third. Do we have the volume of a cone, or can we find it out? Well, we've got the volume of the full container, and we got told that that container can fill 800 cups. So if 63,000 centimeters cubed fills 800 cups, then one single cup is 63,000 divided by 800. Okay. So 63,000 divided by 800 equal to 63, 1, 2, 3, 4, 5, 6, 78.75. Okay, so 78.75 centimeters cubed of liquid going into each of these cups. Okay, so that 78.75 goes into the volume part. That equals the 1/3 times pi times r squared. R is your 3 times h. Okay, 78.75 is equal to, you can tidy that up a wee bit, so 3 squared times pi 9.42 times h. Okay, so 78.75 divided by 9.42 is going to equal h. 78.75. Getting an answer of 8.4 centimeters equals h. Okay, so pretty similar question. Okay, in a previous past paper, we've got a volume. It's actually a wee bit more complicated because we need to divide it by that 800. Okay, dividing it by that 800 gives us a volume target. All right, we get given all the rest of the information. Okay. 0.524, putting that in our calculator. Pi times 7 squared, pi times 7 squared, 153.9 times h. Okay, leaving h on its own, 0.524 all over 153.9. 0.524 divided by 153.9. Give you an answer of 4.34 centimeters. Because that's not 14, that is 1.4, you dummy. 14 centimeter pill would be quite large actually, so that actually makes sense, doesn't it? So that would be different. That would be different. So instead of 7, it would be 1.4 divided by 2, which is 0.7 squared, which is 0.7 squared times pi 1.53 or 1.54. And that would be divided by 1.54 and give us a slightly more realistic answer for h. Okay, so h equals 0.524 divided by 1. Which is 0.34 centimeters in height. All right, so that question's really quite similar to the prelim. Okay, it's just a different starting. All right, it started as a sphere. All right, but the second part of it, we're just rearranging to find a variable that we're not commonly finding. Any questions on the volumes? Volumes? Oh. Question. So one question that was not brilliant in the prelim was the change of subject one. All right. Okay. So change the subject. So given something like that, now that root sign is really important. That root sign is covering everything in here. Okay, now that's important. We'll come back to that. The question asked us to change the formula to G. Okay. Change formula. Subject to G. Okay, so identify G. Pretty obvious. I don't know what G looks like. Okay. What we need to do when we're trying to change the formula is try to isolate that by removing all the noise around it. Okay, by removing all the noise around it. Now we need to do that in a specific order. Now, when we were doing this in class, I spoke about BODMAS or BIDMAS. Okay. And that sort of rings true here as well. Now, this is the order in which we solve equations. Okay, so we always solve equations. We're doing the brackets and orders first, then the division and multiply, then add and subtract. Now, similar when we're trying to get rid of things around, when we're trying to isolate letters, all right, or trying to isolate subjects and formulas, you need to do it in a specific way. Okay, now roots and squares we need to get rid of first. Okay, things around brackets. Okay, now those blue brackets I've drawn in, okay, aren't really there, but because that root covers that whole thing, okay, I can't do anything underneath that root. I can't move any part underneath that root until I get rid of that root sign and move it away. So that's the first thing I need to do. I need to move that root sign across. All right. Now the opposite of rooting something is squaring. So that f becomes squared, and we're left with h plus 3 over g. Okay. Once we get to that point, again, we'll try to isolate g. Okay, but g is in the bottom of a fraction. G is also underneath this whole term here. Again, h plus 3 isn't in a bracket. All right, but h plus 3 is a sort of collective term that we need to move. Okay, but we can't move it individually when g is there. Okay, so we can't move just that 3 across at this stage. Okay, and leave an h on the right hand side. We need to somehow allow that h plus 3 to be its own two parts. Okay, now we do that by moving the g first. The g is a divide on the right hand side, so it becomes a multiply on the left hand side. What that also does is put the g on the correct side for what we want it to be when we finish up. All right, so that g moving to the left hand side at this stage is good for us. All right, it's good for us because we want g to equal something. G now has to become the subject of the formula, so we want it on that left hand side. So moving that g across, we're getting that. So g becomes a multiply. So I've not written the multiply sign, but the multiply would go in there. All right, g times f squared. All right, but when we're just using letters, we don't need to write that. So we just write the gf squared. Now that squared term, importantly, is only assigned to that f. It's not assigned to g at this point. Okay, now that's important because I can't move just that back across and make that a root. Okay, what I need to do to isolate g is move this whole term across. Now it's a multiply on the left hand side, so it becomes a divide on the right hand side. And it goes underneath that whole h plus 3. Right. Found that quite a difficult one. All right, I've certainly seen easier. The root, I think, threw a lot of people. In fact, a lot of it threw a lot of people. All right, so let's finish the night off just by trying that ourselves. Okay, let's finish off the night. So, top one there, changing the formula to B. In fact, tell you what, let's move our page. Give myself space. Okay, changing that formula to B. I'll rewrite it here. It's B equals B plus C squared. What I'm going to do, because B is on the top of that, I'm going to flip that round. Okay, because there's an equal sign there, I can just switch the left-hand side and the right-hand side without changing any symbol or sign. So b plus 4 over c squared is equal to d. Okay, those two lines are exactly the same. I've not done anything to them. Okay, but because it's an equal sign, I can change around the left and right-hand side. Okay, but I need to do everything at the same time. So that leaves a b in the right place. Okay, it's on top. Now, what I need to move first is the bottom of that fraction across. Okay. Again, there's no brackets around the top of that. But that line goes right underneath the b and the 4. Okay, so that c squared is dividing that whole top term. Okay, so c squared moves over to leave that top term as is. Now c squared is on the bottom, that fraction. I'm moving the c and the squared, so I'm moving that whole term at the same time. So I'm not just moving the squared, I'm not just moving the c, I'm moving the whole term at the same time across. Okay, that means b plus 4 is left on the right hand side, and d is multiplied by c squared. Then move the 4 across, bc squared minus 4. Okay, any questions? You good? Cool. Second one's a tough one. Okay, anywhere they throw in this root sign, it's going to be tough. All right, just be aware. I have to rewrite it. L equals root 4 k t. Okay, be aware that that root sign covers that whole term, everything underneath that root sign. Okay, so that root sign has to clear away to allow us to leave what's underneath it. All right, so the first thing we need to do is get rid of that root sign. Well, the first thing we could do is put k on the other side, actually. Let's do that. Let's spin it round. All right, so k is on the right side. All right, so I've not done anything to it. Same, because the equal sign, it's like a seesaw. I'm just spin it around, okay, and it'll just balance. All right. Now I'll move that root and release from it underneath it. It'll become L squared. Okay. We're looking for k. Now, here's again where a few people get lost. This 4 and this t is multiplying with k, so it's 4 times k times t. But these two terms don't do anything to that minus p. Okay, so if we moved that t at this stage, it wouldn't make sense. We have to get rid of that minus p because it's doing something completely different to that k term. Okay, so because the 4 and the t only affect that k term, we have to get rid of that p term first. Okay, that p term, that minus p, affects everything there. Okay. So that minus p is the next part that comes across. So we're left with 4kt L squared, and that minus becomes a positive plus p. Now we can move everything else around that. 4 times k times t means we can move 4 and the t at the same time. All right. 4 can come across and become a divide, and the t comes across and becomes a divide as well. All right, so L squared plus P. They divide everything on our side, so it's 4t. All right, so working with that letter, usually getting rid of things like brackets or square terms or root signs first, and then everything is affecting that whole part of that equation, that whole term. Any questions, guys?